Welcome to the first episode of Ansys CFD tutorials. In this set of tutorials, we will be learning about Ansys Fluent, Ansys CFX, and the basic principles of Ansys Workbench. We will start by learning the basic principles of Ansys Workbench. We can launch Ansys Fluent through two different ways. We can launch Ansys Fluent component in a standalone mode, or we can launch Ansys Fluent as a part of analysis system or as a component through Ansys Workbench. We can launch Ansys Workbench by simply searching for Workbench in Windows search bar. When we launch Workbench, two windows welcomes us. First one is the toolbox window that we see on the left, and the other one is the project schematic window that we see on the right. We can use File to save as in order to save our projects. Under the analysis systems and the component systems, we have all the products presented to us by Ansys. The important one here for us is the Fluid Flow Fluent and the Fluid Flow CFX. We can create a standalone system by clicking and dragging a system from the analysis systems into our project schematic. We can name it by double-clicking this text or simply by directly typing after we create a standalone system by clicking and dragging. We can delete a system by clicking the text here, right-clicking, and then clicking delete. If we have multiple systems that we want to delete, we can also generate a selection box and then hit delete in our keyboard. When we create a standalone system, we see that we have geometry, mesh, setup, solution, and results components given to us in a single module. We can also see that these components are given to us individually under the component systems. Using the component systems has certain advantages. But before talking about that, let's first of all talk about the linkages in Ansys Workbench. Let's imagine that we have a project where we have a geometry, we generate a certain mesh for it, we enter certain boundary values, select the viscosity model, and so on, and obtain the results. Now, without changing the mesh, we want to change the setup. For example, we want to change the inlet velocity. We don't need to generate this entire one again. Instead, we can create another standalone system, and we can share this mesh with this one. We can transfer this mesh to this one. Now, without changing the values for this setup and breaking this project, we have another system with the same mesh and we can enter different setup values. Or, we can directly share the mesh with the setup. This is basically the same thing, but we can make certain changes on this mesh. Whereas in this one, we are directly sharing this mesh with this setup. Now, let's see the advantage of the component systems. In order to understand the advantage of the component systems, let's first build this module using the components given in the component systems. We have the geometry component, we have the mesh component, we have the fluent component, and we have the results component. Now, we can connect the geometry component here into the geometry inside the mesh component, or we can directly transfer. If we directly transfer, this geometry component inside the mesh will disappear. If we don't want this to happen, we can share the geometry inside the geometry component with the mesh. Or we can directly use the mesh component instead of generating another component called geometry. Now we can connect the mesh to our setup and solution to our results. Now, as I said, just like it is with the analysis systems, we can generate multiple Fluent setups and generate our mesh to these setups in order to get multiple setups with the single mesh. We can also copy this setup using duplicate, delete this link here, generate another mesh file, connect our geometry to this one, and connect this mesh to the setup. This way we can have for the same setup two different mesh for the same setup and geometry. However, the true advantage of the component systems comes when we are talking about multiple meshing. Imagine a situation where we want to do a very thorough investigation of the flow field around an object. We can do this by simply generating two different zones of interest. Here is an example. Now ignore my paint skills and focus on this here. This is an airfoil, and let's say we want to investigate the airflow around this airfoil. We can generate this outer box that you see as an enclosure to mimic a wind tunnel, define this part as an inlet, define this part as an outlet, and define these parts as the walls. And this entire field that you see here would represent the flow field. However, when we want to investigate the flow field and the interactions of the flow with the solid surface, we need a very good understanding of what happens around the object. And in order to do that, we can generate this second part that you see. We can also define this as the fluid domain, but model it differently from this outside box. This way, we can generate a medium quality mesh for this outside part where the flow happens far away from the solid body, and we can generate a very high quality mesh for the inside part where the flow is happening around or near the solid body. And in order to do this, there is a simple method. We can obtain two mesh files and generate another mesh file, connect both mesh files to the mesh that you see here. After doing this, we can generate a Fluent component as a standalone system, a results, connect the mesh to setup, and solution to results. Now we can generate what we saw here in the workbench. Another important thing is understanding the layout of the workbench. On the bottom right corner, we see the Show Messages window. In this part, we can see all the error messages that we get. We can clear them by right-clicking and clearing the messages. We have Show Progress window, where if we have a certain progress, for example, we are uploading the mesh from F to C, we can see the progress here. This bottom left corner, here it's written ready. This indicates what is happening inside the workbench. For example, let's delete the link here and hit update. Momentarily you were able to see on the bottom left corner it tried to update. We will understand this more clearly when we deal with simulations. But you should know that all the things that happens inside the workbench is indicated here. That is it for the first episode. In the following episodes, we will start learning about the Ansys Fluent, starting with the geometry components. Thank you for watching.